Welcome to Advanced Algebra with Financial Applications, an Algebra 2 alternative for struggling students.
Hi, I am Rob. I taught mathematics in grades 9 through 12 for 40 years at North Shore High School on Long Island, where I started the finance curriculum in 1977. I am most proud of the fact that from remedial ninth grade programs to an award-winning mathematics research program, all of the books and journal articles I have authored were born and refined in the trenches with thousands of high school students I enjoyed teaching over those 40 years.
And I'm Rich Scroy. My mathematics education career has spanned working with kindergartners through adults. At the school level, I've been a teacher, a chairperson, a 6 through 12 mathematics coordinator, and a K through 12 mathematics director. At the college level, I have taught graduate and undergraduate mathematics and mathematics education courses. My interest is in finding ways to spark student interest and voice in mathematics through applications. I particularly enjoyed my many years being able to teach Advanced Algebra with Financial Applications, the course which Rob and I wrote.
The information in this presentation is excerpted from our book Financial Algebra from Cengage Learning. It is used with their permission.
We encourage you to go to drrsgroi.com. Here you will find Advanced Algebra with Financial Applications resources, downloads, and much more information relating to this presentation.
Let's see how well you think your students relate to the meerkat in this upcoming video.
Since our first equation tells us that y equals 3x plus 2, this means that we can substitute a 3x plus 2 in for the y in our second equation. In other words, since y means the same thing as 3x plus 2, we can replace the y in the second equation with a 3x plus 2. And rewriting our second equation, we now have 7x minus 4 times parentheses 3x plus 2 equals.
Making the case. Why do all high schools need an Advanced Algebra with Financial Applications course?
So let's start with some tongue-in-cheek questions. Which are young adults likely to know more about? APR or APP? Stock splits or celebrity splits? IRS, IRA, or iPhone? Net worth or Netflix? And FICO, FICA, and Facebook? Clearly, the answer is the last one in each group. But the question we should be asking ourselves as teachers is, where are our students going to learn about finance? The Advanced Algebra with Financial Applications program offers students the chance to learn, practice, and employ sophisticated mathematics in a context of real-world topics they are guaranteed to use in their adult lives on a regular basis. This is content that every high school student needs.
We have many stories we could tell about the financial illiteracy exploits of young adults and even adults. We'll tell a few right here. Take a look at this check. My son's best friend graduated from the University of Maryland. I gave him a check. He got a job. The job had direct deposit. The boss said, "Bring in a check." Guess what he did? He brought in my gift check, and they used that routing and account number, and all of his first 4 paychecks were sent into my account. No one in high school ever taught him what a routing number was. Take a look at that sample receipt. My daughter was online at a grocery store, and the cashier was on his cell phone, not paying attention. When she got the bill, the charges were much higher, it turned out that the customer after my daughter was, all their charges were put on my daughter's bill. The supermarket had video. They saw the kid on his cell phone during that transaction and immediately fired him. Advanced algebra for everybody. The audience for the course has traditionally been the struggling students who have been disenfranchised with their school mathematics experiences.
Many high school students are not candidates for Algebra 2 and pre-calculus and need to get a third or fourth year mathematics credit to graduate.
This is not your father's consumer math class from the 50s, 60s, 70s, or 80s. This course teaches advanced, sophisticated algebraic concepts, assuming the student has completed an Algebra 1 prerequisite only. It's not an arithmetic-driven course like those old consumer classes were, or is it a personal finance course in the business or social studies department? Arithmetic-based personal finance courses cannot receive state math credit for graduation. The suggested course name for your school's course catalog and student transcripts is Advanced Algebra with Financial Applications. This assures colleges that the course is not an arithmetic-based personal finance course.
When are we ever going to use this? We've all heard kids say that. One day I took away a kid's cell phone and I started shaking it at him, saying, "You like this thing? Well, be thankful we make everybody take high school mathematics, because the 5% of you who embrace it go on to invent the things the other 95% of you cannot live without. Without high school mathematics, where are we? Yes, we're in the Stone Age." Have you ever gone to a party and told someone you were a mathematics teacher? What do they say? "Oh, I hated math. Oh, God bless you. I always stunk it." Why are they proud of their mathematical illiteracy? The subject we love is reputationally challenged. Even at the dinner table, kid comes home and he failed his 4th grade test on division of fractions, and a parent says to him, "Yeah, I know, I hated it too. Just deal with it." We don't get a lot of public support.
You may be familiar with Charles Schwab and the financial company that he built. He's an American investor, entrepreneur, financial executive, and philanthropist. In a recent interview, he made the following comments about young adults and financial literacy. "It's a national problem that kids are not doing what they should do early in their lives. They lose all those years of compound interest, compound growth, so they really don't find out about investing or what the responsibility is for them to do until maybe they are 30. If I had a magic wand about changing the academic system, I would start in high school with Introduction to Financial Decisions." He's not the only one. This musician and this actor have teamed up to put their support behind a financial literacy app for teenagers. It should be available in the very near future. Back in 2011, Saul Garfunkel and David Mumford wrote an article for the New York Times, and in it they made the following comment: "The traditional high school math sequence is not the only road to mathematical competence. This is our belief, and why we have been working with teachers and administrators throughout the country to underscore this point."
Our love for teaching high school students financial material goes back over 4 decades. Let's give you a little history.
We have each had 4 decades of experience teaching finance to high school mathematics students, and in that time, we have also written textbooks to help students discover mathematics through finance. We have also published articles on teaching finance in math classes in the journals you see here.
This is a project I found in my closet. It's from 1983. where a student had to go to a car dealer physically, introduce himself and have a civil conversation with a car dealer and get all the financial information, and then go to an insurance agent and get the insurance for that car for him in his town, not some fictitious textbook insurance problem. Notice he had business cards to prove he was there, and he also had to write thank you letters to both of the businessmen who helped them. You can imagine how much this helps build school, community, and business relationships.
The student then had to price a loan for that car at 2 different banks. They really get an idea to see what it is going to cost to finance the ownership of an automobile. Again, 2 business cards and 2 thank you letters are handed in with the project. Students usually have 3 to 4 weeks to complete these projects.
Let's now take a closer look at both the mathematics and the finance that are taught in this course. The financial topics are broken down into 11 units: discretionary expenses, banking, credit, owning an automobile, employment basics, income taxes, independent living, investing, starting your own business, retirement planning, and budgeting. And all of these topics include selected topics from Algebra 2, pre-calculus, statistics, trigonometry, probability, and geometry that are taught at a math readiness and ability appropriate level. Scan these topics and you will see that this is not a consumer math course.
Keep in mind, the mathematics prerequisite is only Algebra 1. There are no finance-related prerequisites for the student or the teacher. It will be very easy for you to stay a few days ahead of the students. As teachers, you will benefit tremendously from the knowledge you acquire. How is the course the same as a typical math class? Well, you walk in, there's a do now. There's some motivational problem to kick off the period. Then there is a development of the solution to that problem. Then the teacher gives some more model problems. The students practice a few in class and then for homework. And there are more application problems for homework. How is the course different? Well, there is a lot of passionate discussion. While most mathematics classes have great questions and terrific comments, often it is not passionate when you're discussing the law of cosines. But when students find out that girls pay less than boys for car insurance, they'll be irate. When they find out that the federal tax rate top bracket in the early 60s was 91%, 91 cents out of every dollar went to the federal government, they will get angry. There's a lot of reading because there's a lot of new vocabulary that has to be introduced. We start each lesson off with a quote. You already saw 2 of the projects, but there are dozens more where students will be all over the community. And interestingly, occasionally admitting, I don't know, let's find out. You are not an insurance agent, stockbroker, accountant, IRS agent, etc. So questions will arise and you will have to either turn it over to the kids to do some internet research or call some insurance agents on your own or whatever. There are dozens of projects that serve as worthwhile alternative assessments and extra credit options.
They're usually done over a period of 3 or 4 weeks, and they conclude anything from pricing your own funeral, the most popular project historically over the last 40 years, to the one you saw, pricing a new car, pricing a home closing, pricing a wedding, interviewing a stockbroker, comparison shopping loans, going to supermarkets to compare the price of similar market baskets, etc.
We have found that topic-specific quotes are a great tool that can be infused into any lesson as pre-instructional, co-instructional, or post-instructional activities. Take a look at these 4 quotes. Pause this video and think of math topics where these quotes might be used as part of a lesson. And when you're ready, then restart the video and we will discuss these quotes further. All of these quotes could have been used in any investment lesson. They could have been used for a compound interest lesson. They could have been used for a stock market lesson. They could have been used to talk about risk and reward.
There are many sample pathways to graduation
that can include advanced algebra with financial applications, abbreviated AAWFA in this graphic. Typical is Algebra 1, Geometry, Financial Algebra, and then a STAT course. Notice that 2-year sequence of Financial Algebra and STAT can replace the daunting Algebra 2 and Pre-Calculus for struggling students. There are other variations of the places you can offer these courses on this chart.
Having taught many high school senior-level courses, we know full well what senioritis is. In addition to offering a full-year Advanced Algebra with Financial Applications course to juniors or seniors, some schools have figured out ways to customize a senior year math course. Here are some examples. A fall semester of pre-calculus with topics like matrices, polar coordinates, limits, etc. And then in the spring, 5 chapters of Advanced Algebra with Financial Applications are selected, like automobiles, employment, income taxes, credit, and banking. Together they make a full-year senior-level math course. Another possibility is a fall semester of introductory descriptive statistics and probability, and in the spring, those 5 chapters of Advanced Algebra with Financial Applications. You might say getting a new course on the books is quite a task, and we would agree. If you are thinking of proposing this course, we have a 40-page course proposal document available. Just email one of us for it. But there may be another route. How many of you have courses on the books with names like Discrete Math, Math Topics, College Prep Math, Math 4, Intro to College Math, College Algebra, Bridge Math, Applied Math Concepts, Finite Math, or even Everyday Statistics? Teachers have told us that they've worked with their department chairs to tweak the curriculum in such courses to include financial topics, and it was far easier than starting from scratch with a new course. That's something you might want to consider.
What a terrific elective for everybody. Think of all the finance your valedictorian doesn't graduate knowing. It's a great elective to go along with juniors and seniors taking other traditional mathematics courses like Algebra 2 and/or Pre-Calculus. On back to school night, you're going to hear it from the parents. They're going to express interest in signing up for an adult ed version of this course. Advanced Algebra with Financial Applications has received 2 key approvals. The first is from NCAA. The course has received NCAA approval as a core mathematics course, not as an elective, and can be used in a college preparatory mathematics sequence by potential NCAA college applicants. And for California teachers, the course has UC A through G approval as a C-level core mathematics course. Interestingly, finance topics drive the mathematics applications. So the unit and chapter headings are finance topics, and the mathematics is selected as needed for each of those individual sections, as opposed to the typical mathematics textbook, which has mathematics topics as the titles.
The study of statistics as it relates to financial situations begins in our very first unit, discretionary expenses, and threads throughout all of the units in the course. Here is an example of how statistics can be used in negotiating an automobile transaction. Notice Megan is looking for a used 2015 Chevy Impala and finds these prices. So what we did was we went online and we looked at a local car dealership who had an array of cars that were the same make, model, and condition. And we noted the mileage and the price for each of those cars. And then as a class we wondered, is there any mathematical relationship between the mileage and the price? And we did a scatter plot and a linear regression. Once we got the linear regression formula, we went back to that same website and found another car of the same make, model, and condition and noted its mileage and its price. We put the mileage, the x value, into our regression formula to see what the price should be based upon that regression formula, and then we compared it to the actual price the dealership was charging. Another thing that we did was we took all the prices and we made a modified box and whisker plot. Notice you can see with the plot where the quartiles are, where the median price is, and where the outlier lies.
The course includes a full treatment of the normal curve, percentiles, and z-scores. Imagine the financial ramifications for this auto insurance scenario. Molly runs a stop sign and hits a telephone pole and bounces into a minivan, injuring 8 people. 3 people in Molly's car are also hurt. The minivan's driver was a concert violinist.
The injury to his hand means he can never work again. He sues for $40 million and is awarded that money in court. How much will the insurance company pay? How much is Molly personally liable to pay? If you're a licensed driver, you have to know the answers to these questions. Which is why it drives us crazy when we see these commercials for purchasing insurance in under 15 minutes. A car insurance purchase should involve a discussion on costs for different coverages and coverage limits. It is not something to be rushed.
Another real-world application of mathematics as it relates to the automobile is in accident reconstruction. In some accidents, an accident reconstructionist who has knowledge of both crime scene investigations and mathematics can help make sense of the circumstances surrounding an accident. To reconstruct the approximate speed of a car entering into a skid, the reconstructionist uses the square root function skid speed formula. More often than not, accidents can be avoided if drivers really understood the mathematics of reaction distance and braking distance. In both cases, a good approximation can be achieved by just knowing the speed at which the car is traveling just before the brake pedal is pressed. The reaction distance formula is a simple arithmetic calculation, and the braking distance formula is a quadratic function. You will be asked to refer to and use these two formulas in the activity on the next slide. The usual reaction time for a driver is about 3/4 of a second. That is, it takes about 3/4 of a second for an alert driver from the time he or she realizes the brakes need to be applied to the time the foot hits the brake pedal. A car traveling at 55 miles per hour is traveling at about 80 feet per second. This can easily be determined by setting up equivalences of miles per hour to miles per minute to miles per second to feet per second. In about 3/4 of a second, a car travels 60 feet when going 55 miles per hour. That's quite a revelation to many students. But what happens to the reaction time when the driver is distracted or impaired in some way? It increases, which causes the reaction distance to increase as well. You will now do an eye-opening activity that simulates how far a car traveling at 55 miles per hour goes during the time a driver is distracted because of texting. In the classroom, I would ask students to take out their phones and on my signal, write the text, "On my way, see you soon," as I time them. I ask them to raise their hands when completed, and I stop the timer when about half the class is done. I give them that time. Then I ask them to determine how far a car would travel at 55 miles per hour during the time the text was written. Pause this video and try this simulation using your cell phone and a timer. Once you have accounted for the time it takes to write the text, go to the previous slide and use the formulas there to determine the total stopping distance. The approximate stopping distance is the sum of the reaction and the braking distances. Assume that the car you were driving was traveling at 55 miles per hour. You've probably heard the statement, a car loses value the moment you drive it off the lot. This may be true, but just how does a car depreciate? In this course, we study 3 kinds of depreciation. The first is linear depreciation, where the car loses the same amount over specified intervals. In actuality, there's not much in the real world that depreciates linearly. But we include it in this course because the Internal Revenue Service requires taxpayers to use a straight-line depreciation formula for depreciation deductions. The example at the bottom is a system of linear equations in which one equation is the auto expense equation and the other is the straight-line depreciation equation. We ask students to tell the story on the intervals before and after the intersection point and at the intersection point. Pause the video here. What are those stories? Welcome back. Before the intersection point, the car is worth more than the money put into it. The intersection point is the break-even point, and on the interval greater than the x value of the intersection point is where the expense is greater than the value of the car. The other depreciation methods are exponential, involving a depreciation rate, and something modeled by a bathtub curve. The bathtub curve is a piecewise function where the x-axis represents time and the y-axis represents the value of the car. Just what type of car is depicted here? You guessed it, it's a classic or a vintage car. At first, the car depreciates in value, then it levels off, and then at some point in time, it begins to appreciate.
The course also covers arithmetic and geometric series, the famous penny doubled every day problem, that paper folding to reach the sun problem. Weekly direct deposits into savings are an arithmetic sequence, even if you put the same amount of change into a jar each day at the end of the day. Down payment and monthly payments, layaway, and depreciation are examples of arithmetic and geometric series. The penny doubled every day problem fascinates students. A lot of them go home and they try to make deals with their parents to rake the leaves or something like that with this pay scenario. But give them a calculator and let them just start with 1 cent, then 2 cents, then 4 cents, and watch how by the 28th day, over $1 million is earned for just the 28th day. A similar problem introduces exponential functions. You take a sheet of paper and measure it. How do you measure its thickness? Well, take a ream, which is 500 sheets and about 2 inches, and just divide. Thickness is approximately 4/1000ths of an inch. Imagine folding it several times. Each time the thickness doubles, so we have an exponential function, just like the penny doubled every day. How many times would you have to fold it so it would be thick enough to reach from the earth to the sun? Now, this can be done arithmetically or algebraically using exponential functions. Amazingly, and I leave this to kids to find out over the period, only 51 folds of that paper will have it reach 93 million miles. Let's take a look at getting a feel for compound interest, because before there's a formula, students have to intrinsically understand what it is, and the expression getting interest on your interest doesn't really explain it. Let's take a look at Jennifer, who has a bank account that compounds interest daily at a rate of 1.2%. On the morning of June 18th, the principal is $1,234.98, and there it is entered in the calendar. On June 18th, she withdraws $200, and there it is in the calendar. On that same day, June 18th, a direct deposit paycheck is made into the same account. Now, the principal used to compute the interest can be computed by subtracting the withdrawal and adding the deposit. The day's interest is computed by multiplying by the percent and then dividing by 365. This answer for these purposes is rounded off to the nearest cent. That 5 cents daily interest is now added to make an ending balance of $1,376.03.
Notice the ending balance for June 18th is also the opening balance for June 19th. Now students can see what getting interest on your interest means, because that 5 cents interest is now included in the amount to compute the interest for the next day. On June 19th, she deposits $2,300 from selling her car. Also on June 19th, an auto pay for her $91.22 phone bill is subtracted. Press pause and you try this. What is her balance at the end of the day on June 19th? Finish the calendar. Here are the answers for June 19th.
That arithmetic progression of compounding interest leads us to the algebraic derivation of the compound interest formula. We all do a significant amount of problem solving in our classrooms, but research tells us that we may need to incorporate problem posing as well. In this course, we offer students opportunities to problem pose in a recurring activity we call What's the Problem? Here is an example. Students are given exactly what you see here in black on this slide. Examine the equation below used for determining the balance on a bank account. Write a problem that could be modeled by this equation. We ask that you pause the video here. Write an application problem that would use both the data and the formula above in its solution. If need be, you can find the compound interest formula on the previous slide. Here is a sample solution. Kim made a $2,500 deposit into her savings account at First National Bank. Her bank offers an annual percentage rate of 1.7% and compounds interest daily. How much will she have in her account after 3 years? If students can accomplish this task, you will gain insight into student understanding of the compound interest formula. You could also offer this in differentiated tiers by adjusting the formula statement. For example, by changing the exponent to 1095, you could assess if students can extract the term of the account by dividing. We also derive the continuous compounding formula in an ability-appropriate way, recognizing that the prerequisite for the course is only Algebra 1. Students use tables on a calculator to look for a pattern and evaluate E as a limit. Then they use the formula B equals P e to the RT, or the PERT formula, to compute continuous compounding.
Studying consumer credit involves lots of vocabulary words. It also involves a funky formula where even with a calculator, you have to be very careful with parentheses when substituting in this formula. It is really important for students and young adults to learn about the payoff box on the monthly credit card statement, because if they only pay
The minimum payment, it is extremely more expensive in interest payments to pay off the bill, even if no new purchases are made. And you can look at this and see the difference, 22 years against 3 years. Mortgages. When you walk into a bank, they don't ask you to find cosine of 30 degrees. There's a lot of vocabulary on a very long, finely printed paper, and you have to be sure you understand it. Now, we teach it in high school, but in reality, students may not apply for a mortgage for a dozen years after they graduate from high school. The important thing is they learn the terms, and if they just remember that they learn the terms and how important it was to revisit them to make sure they understood the mortgage document, that is a great lesson for them to learn, whether or not they have forgotten the vocabulary in the interim.
It is very important that students understand the mathematics of student loans. In 2019, the Wall Street Journal reported that trailing only mortgages, student loans are now the second largest form of consumer debt in the United States. So we explore the following questions in this course. How much interest will I pay? How do I calculate my monthly payment? Should I make interest-only payments while I'm in school? Am I eligible for a tuition tax credit? Am I eligible for a student loan interest deduction? We also address another form of loan, the short-term payday loan. This type of loan is available in many states, but it is illegal in about 14 of them, so it is important to study. What follows is the voice of a congresswoman from California and her interview with a member of the Consumer Finance Protection Board. Jot down some of the information since you will be asked a question at the end of it.
Let's do an example. I'm a single mom. I'm by the side of the road. My car is broken down. I need money right now. I pick up my cell phone. I go to Speedy Cash, an online lender. I'm in California. I have to get to work. I have to have the cash to fix my car to get to work. I can barely read the little disclosure on my phone. The cost at Speedy Cash is, you may want to write this down, $10 per $100 borrowed. I need $200 to fix my car. The origination fee is $20. The term of the loan is 2 weeks, typical for when I get paid. What is the APR? And if you'd like a calculator, we have one for you.
Please pause this presentation at the end of my explanation on this slide and calculate the annual percentage rate for the payday loan we just discussed. Here, the loan interest is $20 for the origination fee and $20 for that loan amount, or $40. The loan amount is $200, and the length of the loan is 14 days. We can develop the formula by using the simple interest formula, I equals principal times rate times time. And with a little manipulation, we solve for R. Notice that R is equal to I divided by P divided by T. Therefore, the payday annual percentage rate is equal to the loan interest over the loan amount. But now, because it's the annual percentage rate, we need to rewrite 14 days as an equivalence in years. And that is accomplished by just dividing that loan length by 365. And also, because we're looking for a percentage, we multiply the entire answer by 100. Okay, pause it now and try this example. What was the annual percentage rate for that particular payday loan? You're back. Were you shocked? Approximately 521% was the APR. In addition to that big amount, 80% of payday loans are rolled over, followed by another loan. This is incredible information. And we need to be aware of the fact that there are lenders who are taking advantage of people. As I said before, payday loans aren't available in all states in the United States. Look for your state. If the state here is represented in gray, then payday loans are illegal in that state. The other colors are gradations of what the approximate interest rate maximums are in each of the states.
There is so much trigonometry and algebra and geometry involved in owning a home. So the course includes the sine, cosine, tangent, slope, the Pythagorean theorem, rise over run, similar triangles, and pitch. All of things which affect you, whether you want to see if a tree's going to fall on your house, you want to see if it's safe to go up on your roof, or you want to build a deck and make sure it's square. How many BTUs do I need for my air conditioner? Another major question for homeowners. Well, you don't want to over or underbuy BTUs when purchasing an air conditioner. Notice, this is a function of 5 independent variables that are explained in that text box.
Many students enrolled in this course have part-time jobs. They see that money is deducted from their pay but rarely know what it is for. So we include in our discussions the taxes imposed under the Federal Insurance Contributions Act, or FICA. These are Social Security and Medicare payroll taxes. Take a look at the tax year 2020. The Social Security tax had a maximum salary of $137,700. The tax rate for that year is 6.2% of all gross earnings up to and including $137,700. The Social Security tax for any given year can be expressed as a piecewise function, and the graph of that function has a cusp. The piecewise function in blue represents the Social Security function for 2020. Back in 2012, the federal government lowered the Social Security percentage to infuse more money into the economy. Notice the Social Security percentage dropped from the usual 6.2% to 4.2%. You should also notice that the maximum salary at that time was lower as well. Students are given the opportunity to create and examine the piecewise functions, as well as to interpret the different slopes, to find the cusp, and give the coordinates of the cusp. Our progressive tax system is filled with tax tables, tax schedules, and tax worksheets that are used by taxpayers to calculate the amount owed to the government. Here is a tax schedule that is used by single taxpayers. The income intervals are stipulated along with how the tax should be calculated on each interval. These schedules are really piecewise functions organized as charts. Each line in Schedule X translates to an applicable formula on a taxable income interval. But translating schedules into functions is beyond what is expected of taxpayers. As a matter of fact, the schedules are now used for verification purposes since the IRS decided to simplify the process. Schedule X, shown here, has now morphed into Worksheet Section A. And the IRS directions simply boil down to yours is not to reason why, just subtract and multiply. But where do these magic numbers come from? Expressed algebraically, line 5 of Schedule X looks like this. Apply the distributive property and put it in y equals mx plus b form to get this simplified equation. Notice what it says. If x is your taxable income, multiply x by 0.33 and then subtract 15,103 from it to calculate your tax. See anything familiar in the second line of Section A? Schedule X mathematically became the Section A worksheet.
The first day of the unit on modeling a business startup involves the students thinking of original inventions. To kickstart them, we talk about things like the straw, the paper clip, that pizza saver, which how many millions of those are used every day to keep the cheese off the cardboard. So we have the students brainstorming and they come up with some pretty interesting ideas, and then we start the unit. And many of the students have seen examples of this because they watch Shark Tank. Most mathematics teachers are hard-pressed to show their Algebra 2 classes an actual application of imaginary numbers. We've all heard that it's used in electricity, but that the example is too advanced to be able to show to a high school class. Well, in the financial algebra program, we have an application of imaginary numbers in our modeling the starting of a business unit. And basically, what does profit parabola with imaginary roots imply? So the students are going to see an application of imaginary numbers.
Examine these graphs. In each case, the blue graph represents a linear expense function, and the black graph represents a quadratic revenue function. Profit is equal to the difference between revenue and expense at a given price. Pause this presentation now and write a description of the profit situation in terms of the revenue and expense functions for each of the graphs. Your solutions should be similar to these. In graph A, the expense is constant and not determined by the price. There are two break-even points. The price producing the maximum profit is the x value of the vertex of the revenue function. In graph B, the expense decreases as the price increases. There are two different prices for which there is a break-even point, with the maximum profit point somewhere between the two break-even points. Graph C is a sad situation. The expense function is always above the revenue function. There is no profit to be made in this situation. And in graph D, this situation is similar to B, but the expenses are less. The profit to be made will be greater than that in B. Cell phone minutes and data rates for many carriers can be expressed as a piecewise function using greatest integer notation.
Students are shown how life insurance companies can compute their profit
using mortality rates. The Advanced Algebra with Financial Applications program includes many sophisticated statistics topics. The central limit theorem, combinations, convenience samples, hypothesis testing, random number tables, mean absolute deviation. Just take a look at this list. One of the nice things about it is that statistics don't have a lot of prerequisites. So if you are not good at trigonometry or geometry proofs, that won't affect your clean slate for studying statistics.
Students learn how to design completely randomized experimental designs, which are used to compare, in this example, the effectiveness of two different light bulbs.
In the budget unit, we stress data organization. Matrices are convenient means of data storage, data labeling, and data calculations. Spreadsheets and household budgets combine all of the expenses addressed in the 11 units of the course. Notice that a household budget can be viewed as a large matrix. Here, students learn how to use algebra to set up cell formulas when creating spreadsheets for budgets, cash flow, and debt reduction analysis.
Because Advanced Algebra with Financial Applications is a real-life course, there are no fabricated numbers designed to make problems come out easy. So a calculator in some form is essential. Many schools use the TI-84. The Casios are much less expensive than the TIs. Desmos.com, Excel spreadsheets, and the Pacific T graphing calculator are just a few of the many options, so all students can have access to a calculator at all times.
Well, that's it. We want to again thank National Geographic and Cengage Learning for allowing us to use excerpts from the book Financial Algebra. If you have any questions at all, feel free to contact us at either of these two email addresses, or if you want more information, you can also find it at the website drrsgroi.com.
If you enjoyed this presentation, you might want to view our other presentation, which is a potpourri of activities you can use to fortify the first 5 minutes. We call it Do Nows Done Better, and there are 18 different strategies you can use to purposefully begin any mathematics class.